not that common. Okay, it's possible, but not that common. But you'll see sometimes, not a lot, sometimes you might find that the pH answer is, say, -1 or 14.3, that is outside of your pH range. That is possible. Okay, it might be that it's very concentrated, or that somewhere the calculation is off, or. So it is possible to get a pH of -1 or 14.3, but the chances that that will happen is quite slim. If you get something like a pH of -3, then you know, okay, there's a mistake. Okay, but -1, -0.5, something like that is still possible. Okay, then I know I didn't give it as homework, but I quickly want to look at question 7 together.
Yeah.
Yes.
Do you ever unplug the charger?
Do I have?
Do you ever unplug the charger?
Unplug the charger. Yes, every day.
It's cool.
Thank you. Yes. Yes, but where's your chemistry book?
This is there. You have the chemistry issue, unfortunately.
I'm going to give you notes because I am not that happy with the work. So I'm going through it again slowly. So the chances that we will have extra classes is getting bigger and bigger and bigger.
Don't worry. You will be like taking care of us, or some of us they will go to groove. So yeah, we'll come.
Go to groove. Like party.
Yeah, yeah.
But how old are you, Tiamo, when you speak about groove?
It's 18.
Like, no, I just mean my parents
Man.
spoke about
These people,
groove.
These people are born inside groove. Oh.
Like, yeah, you speak like an old man.
Oh, what must I say?
Party. Okay, right, so question 7. You can make a star there for yourself. This is a good exam type of question. No, at the homework question 7. It was not for homework. Okay, so at question 7, I want you to open the question also next to you. It says there, calculate the mass. So now they want the mass. And they say there of sodium hydroxide that will need to make a 1 decimeters cubed solution. What do they give us there? 1 decimeters cubed. Volume. And then they say the pH of that solution must be 13. Okay, so that's the information that they give us. And they say we must get the mass. Okay, right. So this is almost like a reverse question. They give you the pH. So my planning first. If I have the pH, then I can get the concentration of my hydronium ion. Okay, but I don't work with an acid, hydronium ion. I'm working with a base. So in a certain way, I must get from an acid, hydronium ion, to the base. How do I do that? That ionization constant of water. So if I have that, then I can get the concentration of the hydroxide ion. If I have the concentration of the hydroxide ion, I can get the concentration of the sodium hydroxide. And then there's a formula, C is M over M times V. Then I can get the mass. So there's 4 steps in here. Okay, I'm going to go through it again. They ask the mass, they give the pH. So say, right, the pH will give me this concentration. I want to work with a base. So in some way, I must go from an acid to a base, and I use the ionization constant of water to get the concentration of the base. Then I'm going to look at the dissociation reaction. See, the ratio is 1 to 1. So if I have that one's concentration, I have the volume that was given, I get the molar mass, I can calculate the mass. That was the question. Okay, I've said this before and I'm saying it now again. In this type of question, in acid bases, there's a lot of planning. Planning. Okay, right. So let's start. So we're going to start with the pH is negative log concentration of the hydronium ion. The pH is 13, negative log. Okay, now I don't think we've done this before. I think we stopped before this. Okay, so I'm going to do this slowly, step by step, how you do it. First, you take the negative over to the other side. Have we done it the opposite like this? What? Okay. Then you're going to divide by log. If you say with sin, cos, and tan, if you divide by sin, cos, and tan, what do you press on your calculator? Shift. Okay, so the same thing here. I'm just going to write it like this. You're going to get that concentration. You're going to type into your calculator shift log negative 13. And what you're going to see on your calculator, on the screen, is going to show 10 to the power negative 13. Okay, so I want you to quickly take out your calculator, please. Okay, and I want you to press in shift log. And then you see it gives you 10 to the power of, you type in negative 13. Okay. That happens when you eat on your own, Selma.
You eat sweets with ice. Not with ice, balloon with ice. You eat it and you don't give it, you don't give us.
When I eat it, I always give you.
When you answer.
Yes.
Here's one for you, here's one for you, let's all eat.
That's true.
This one,
But I answer all your questions. And where's my sweet?
I know you get the pride, like, yeah.
All right. So we have this concentration. Now we want to go to that concentration with the help of the ionization constant of water. So we're going to use that. That formula you will find on your data sheet with this value, so don't go memorize it. Remember, when you fill in a concentration, you lose the square brackets. And then we get that concentration to be 1 times 10 to the power negative 1 or 0.1. What's wrong? That is that value that you filled in here. Wait, that value you filled in there, so it's negative 13. In which class does the periods go fast? No, but like which one? Afrikaans.
No. Afrikaans. Yeah, but it's Afrikaans. Maybe this one and that. It's like two hours each. And Greek.
Okay, right. So we've done that, we've done that, we've done that. Now I want to get the concentration of the sodium hydroxide. So I'm going to look at the dissociation reaction. Okay, where it splits up. The only thing we show there is that the ratio is 1 to 1. So you can either say it's 1 to 1, or you can just say after that, that means the concentration of sodium hydroxide is the same as the concentration of the hydroxide, which is 0.1. Okay, remember you must understand what you write down. If you don't understand, you must ask. Alright, and now, so we did this, and now we're going to use that formula to get the mass. So we say concentration is mass over molar mass times volume. The concentration is 0.1. We want the mass. We need the molar mass. Okay, of what? Of sodium hydroxide. So that is 23 plus 16 plus 1, which gives you 40. And they said all the way at the top. I'm just going to quickly show you. At the top, they said the volume is 1 decimeters cubed, so the volume is 1. And if you calculate the mass, you get that to be 4 grams.
So that's probably like 10 marks.
Ooh, let me just check. This will be 1, 2, 3, 4, 5, 6, 7 marks. 7 marks. Okay, right, don't back away just yet. So, this here is good preparation for your practical. Okay, because your practical is split up into 2 parts. The first part is you must make a standard solution. Now, standard solution is one of which the exact concentration is known. One of which you know the concentration of. Okay, the linear. Ja, is reg, dankie. Okay, so one of which the exact concentration is known. So I'm going to tell you in the practical, make a solution with a concentration of, I'm going to say, let's say 0.1 or 0.2 or whatever. Then you must go determine but what mass must you measure off on the scale to get that concentration. Okay, are you with me? Now that I think of it. Nee, dit is met een verkeerde spaal gedaan. Never mind. Okay, so one which the exact concentration is known of. So you are going to go measure off that mass and you're going to put it in your container. Now that container is called a volumetric flask. A volumetric flask. Okay. Now in the science lab, this is the only apparatus that is 100% accurate. Except for one other thing, but I'll tell you. But this is very, very accurate. All your other glass beakers, this 250 mils and this one, they are all inaccurate. It's just a quick measurement. Why is it inaccurate? Because glass, when they make it in the factories, glass, the thickness varies. Okay, it's very difficult because it's very viscous. It's very difficult to pour it, so the thickness varies. But this one, they hand make it. In what sense? They make this whole container with a big machine, but then they go, there's a small line, I'm going to send this around, now there's a small line there, and there they measure, say this is to be 250, they measure it off to be 250, and there where 250 is, they make a small line with the hand. So if you have yours, and your friend in the practical have their volumetric flask, you'll see the line is in a different place, because for each one it's hand measured how much, or up until where it's 250. Yes. Okay, right. Did you see the line? Okay, I'm going to say this around. So you see, that's called the volumetric flask. Volumetric flask. So you're going to make that the solution with that. Okay. Then I want you to also note that is 4 grams a lot? Is 4 grams a lot? No. No. Okay. Is a pH of 13 quite high? Very high. The highest you can go is 40. So this means it's a strong base, but the mass that you measure is very little. Okay? So I want you to connect that just because the mass is small doesn't mean the pH is not high. The pH has to do with the strength of the acid and the base. Is a sodium hydroxide a strong base? Yes, it's a very strong base. Okay? Are you focusing? This is a very strong base. So the 4 grams has nothing to do with if it's strong or weak. Okay? The 4 grams will just give you the size for the volume of the container. Okay? But the pH is linked to how strong or how weak the acid or the base is, how well it dissociates. Okay? So there are definitions of what is a strong acid and what is a strong base. That is important. Okay. And we have done that. Yes. So we did it here. What is a strong acid? It ionizes completely to form a high concentration. What is a strong base? It dissociates completely to form a high concentration. Okay. Right. We are busy calculating pH formulas. pH values. Okay, so this question 6 is a lot like your homework question 7 we just did. It says that 9.8 grams of sulfuric acid is dissolved in 500 milliliters of water. What is the pH of the solution? Okay, planning. They want the pH, and for that I need the concentration of the hydronium ion. Okay, so I'm not writing down the full formula now. They tell me the mass is 9.8 grams. They say we are busy with sulfuric acid. Okay, now the reason why they give us that is twofold. Number one is to get the molar mass, and you don't have to calculate it now, it's 98, you can believe me. And then the second thing is, can you see this 2 there? Okay, that 2 is causes this acid to be a diprotic acid. A diprotic acid. What does di mean? 2. Protic? No, don't think about organic chemistry. Protic, it stands for proton. Okay, so if this says it is a diprotic acid, it means the di stands for 2 and the protic stands for proton. So it says it gives away 2 protons. Okay, and I'm going to explain this probably about 4 times in this chapter. Here comes the first explanation. Why do they speak about a proton? Okay, can I zoom in? If we look at hydrogen, how many protons does it have? 1. How many electrons does it have? 1. How many neutrons does it have? 0, because the mass of hydrogen is 1, and the mass is the protons and the neutrons, so it has 0 neutrons. If we look at the hydrogen ion, okay, how many protons will it have? 1. How many electrons will it have? If it is a a hydrogen ion, plus it means it lost an electron. It only had 1 electron and now it lost it. So how many electrons does it have? 0. How many neutrons does it have? 0. So, can you see that a hydrogen ion is just a proton? Because there's nothing else there. So you can either speak about a hydrogen ion or you can speak about a proton. They are the same thing. Like I said yesterday, what is the same thing? I also said that the hydronium ion is the same thing as the hydrogen ion. They're the same concept in this chapter. The same thing here. A hydrogen ion is the same as a proton. Okay, right. So, if I say this is a diprotic acid, I mean it can give away 2 hydrogen ions. It can give away 2 protons. Okay. Right. So that is what they give us there. And then the last piece of information is the volume. They say the volume is 500 milliliters. Do we work in milliliters? No, we work in liters. So times 10 to the power negative 3, and that gives you 0.5. Okay, let me just go over my planning. Did I maybe miss something? We want to get the pH with that. We don't have that. We do have information regarding sulfuric acid. Can I go from sulfuric acid to that? Yes, with the help of the ionization reaction. It reacts with water to give you blah, 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 blah. So I must write the ionization reaction, and then I have all the information is regarding sulfuric acid. So if I must first get his concentration to get the concentration of that. Okay, so there's 3 steps here. Okay, so I'm going to first start with the concentration of sulfuric acid is mass over molar mass times volume. Okay, the mass is 9.8, the molar mass is 98, and the volume is 0.5. And if you calculate that, let's start somewhere. Katleho. 9.8, yes. Which is 0.2. Okay, so what do I have now? I have the concentration of sulfuric acid. I want the concentration of hydronium ion. So I must write the dissociation reaction. No, not the dissociation, ionization. So we have sulfuric acid reacts with water to give you the hydronium ion and the sulfate ion. Okay, but it's not balanced. This we said is a diprotic acid. Now, if it is a diprotic acid, it gives away 2 hydrogens, which means it can form 2 hydroniums. Okay, so you can know now until you die one day, if it is a diprotic acid, there's a 2, then you can put a 2 there and a 2 there to balance it. If there's a 1, then it's 1, 1. If there's a 3, it's 3, 3. Okay, so we see the mole ratio is 1 to 2. So the mole ratio is 1 to 2. This concentration is 0.2. So what is hydronium's concentration? 0.4. Okay, now that we have this concentration, we can go calculate the pH. So pH is negative log concentration of the hydronium ion. So negative log, and remember when you fill that in, the square bracket falls away. And cananelo. Yeah, 0.4. All right. Did I say which? Next one, not a bit more difficult, but just different. They ask calculate the pH of that solution and determine the indicator that will be used. Okay, right. So they want the pH, and for that we need the concentration of the hydronium ion. They say we have the concentration of sodium hydroxide is 0.25. Yeah. Okay, so we want that, we have that. How are we going to go from that concentration to that concentration? Yes, the ionization constant of water. But before we do that, we must first get the concentration of the hydroxide ion. Okay, so we must show that it ionizes or it dissociates. Okay, so we're going to say sodium hydroxide splits up into the sodium ion and the hydroxide ion. So the mole ratio is 1 to 1. So if this one is 0.25, then this one is 0.25. Okay, so I use that, I have that. Now I'm going to use the ionization constant of water to get the concentration of the hydronium ion. So we're going to say, right, the hydronium ion times the hydroxide ion gives you 1 times 10 to the power negative 14. Remember, you find that on your data sheet. And if you calculate that, Tape law. Say again.
4 times 10 to the power of minus 4.
Say again.
4 times 10 to the power of
What?
2.5.
No. What are you going to do? Currently you're multiplying there. So you want to get rid of it. How do you get rid of it?
Well, I swap. I put the 0.5 first.
Cancel the beginning of
It's around like it never lasts. Yeah. 4 times 10 to the power of 4.
Moet ons Afrikaans praat vandag? Oh, het sal so lekker wees.
Allemaal van ons wil hier.
Okay, goed. So nadat ons dit gedoen het, wat vra hulle die PA?
Ja, moet jy iets dat dan is weer bond.
O, het jy nog steeds jou Afrikaanse notas?
Weet ek is al weet.
Alright. Wat jy Melu, you on it? Is jy op het?
As wat die mosse.
Maar julle moet bietjie julle Afrikaans oefen. Dis dan julle gunsteling periode.
Ons is nie meer rugby.
Ons wil getrou.
Jy wil wat word?
Hulle wil sê polisie wees trou met.
Wil jy getrou of vertrou word?
Ek sit vertrou.
Jy sien weet ek is. Hy wil wat jy call it? Hulle wil
Afrikaanse vrou.
Ja. Dis tot kry dis hier. Hulle is so opgewonde vir wie.
Vir wie vir jou? Hulle kan mos trou met wie hulle wil. Well, if that person wants to marry, then they can.
Maar vir wie ons hulle die swankies dan so. Hulle moet kom collect.
Kom.
But the answer is 13. We don't understand.
Jou boy Melu?
13.
13, moet nog ja, dit gaan afrond. Dis nie 14 nie, want dit is 13,398. So daai maak hom vol, wat hom vol maak, dit word 'n 4.
Die eerste een, die nommer 6, ons het gesê dit is 0.4.
Ja, want
Die dinge is
sy antwoord was gewees 0,3979. So dan gaan daai hom verander, wat hom gaan verander.
Kom balsa, wat is 'n woord vir dit?
Staan jy? Okay, mooi. Goed, laaste ene. Sê hulle vir jou, die pH is 6,4. Okay, dan vra ek vir jou bereken albei daai konsentrasies. Yes. Oh yes, thank you. Sorry, they asked for which indicator should be used. Vanille, watter indikator gaan gebruik word in Afrikaans?
Dit is die tan en die oh. Wag even.
So lekker.
Dit is die fenolphthalein. Fenolphthalein.
Maar wat stel je nou voor kans?
Phenolphthalein.
Fenolphthalein.
Dit is die van die
It's just instead of a PH, it's an F. And there's no H in. All right. Thank you, Potimilu. Last one, they say, not the last, yes, the last one. They say the pH of the solution is 6.4 and then they ask calculate the concentration of both of them. Okay. So, hoe bereken jy die pH? Dis die negatief laag van die konsentrasie van die hydronium-ioon. Okay, so ons kan baie maklik gaan van daar tot by daar. En dan vra hulle vir jou ook die konsentrasie van die hydroksied-ioon. Hoe gaan jy van die hydronium-ioon na die hydroksied-ioon toe?
Water. Enogesuur.
Die ionisasiekonstante van water.
Moet dit always be like this?
Wat? The Afrikaans? No.
Dan you hyping them up man. Wat sê jy?
Ons verstaan nie die groot kop nie of hy.
Dat jy hypoxie hulle. Ja,
Dis motiveer.
jy hyping hulle te veel. Ja, hypoxie. You're hyping them man, like, you see now.
Wat sê jy?
Have to focus, come on. Engels. Of al pad soetu.
Coming from you.
Juffrou,
Pad soetu.
sê mense is Afrikaans, jy moet leer.
Wat bedoel dat?
Excuse me, wat het jy gesê?
Wat sê
Afrikaans is morgen, is morgen.
Wat sê jy?
Ek het ook nou net iets gehoor wat ek nie moes hoor nie.
Is morgen, is morgen.
Wat is nie op die kam? Wat sê jy?
Chichi, are you calculating?
Oh yes.
Oh yes. Then I don't have to think so much.
Wat?
3.4 times 10.
Oh, jee. Dis 4 punt.
Dit-
Dis 4.
So say again, sorry? So sorry, this is not your final answer, so don't round off just yet.
So it's 3.981.
Times 10 to the power negative 7. Hey. Yes. Yes. First put the negative over and then shift log. Katlejo, are you checking him? You are very quiet today. It makes me nervous when you are this quiet. Alright, so now that we have that concentration, we're going to use the ionization constant of water to get the concentration of the hydroxide ion. And Unatio, you're on it.
Messier.
Yes. Yes. Negative? Negative? And your unit? Because we calculate concentration. Decimeters cubed. Alright, now Miles, my question to you is, if the pH is around 6.4, is it more acidic or more basic? The pH is from 0 to 14. 0 is acidic and 14 is basic. So which one is it closer to? To 0, so it's more acidic. So we expect the concentration of the acid to be greater than the concentration of the base. Is that true? Is -7 bigger than -8?
Yes.
Yes. Okay, so that's how you check your answer. Okay, right, next one. Going. 5, 4, 3, 2. Katlejo, are you sharp?
Yes.
Okay. Right. Now, back in the day, they came up with definition, something to define what an acid and a base is. So this guy, his surname was Arrhenius. He came up with a definition. He said that an acid is a substance that produces hydrogen ions in water, and a base is something that produces hydroxide ions in water. And that was the definition for very, 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 very long. Okay. So, obviously that I'm indicating that we have new definitions now, but unfortunately, fortunately, you must still know these definitions. Okay, so this old Arrhenius definition, you must still know them. They don't ask them that often, but they do ask it. Okay, so they say then acid produces hydrogen ions and a base produces hydroxide ions. Okay, right, now let's look at how we apply that definition or how it makes sense to us. Okay, if we look there at the first one, what's the first one's name? There is a nitrogen in.
Nitrogen 9.
Yeah. Pelo? Hey. Go to the last page in your notes.
It's a nitric acid.
It's just nitric acid. You should know these names. Nitric acid. Okay. So they say when you take this nitric acid and you dissolve it in water, you get an hydrogen ion and you get a nitrate ion. Right. So far, Arrhenius's definition makes sense. An acid produces hydrogen ions. Okay? But after a lot of experiments, they found that this doesn't actually happen. Okay? It doesn't split up in water. What actually happens is that the nitric acid reacts with water. Okay? And that gives you an hydronium ion and a nitrate ion. So here it dissolves in water and here it reacts with water. So the water is above the arrow and the other one, the water is in front of the arrow. Okay, but it's still not the end of the world. I'll be right there. It's still not the end of the world because we said the hydrogen ion and the hydronium ion means the same thing. So you'll get the same type of reaction or answer when you do that. Hello. Where are you going?
Yeah.
When do I see you after this? All right. Then if we look at the next one, ammonia. Okay. Ammonia, when that reacts with water, so that is, you all know the name, ammonia, ammonia, ammonia. Yes? Did you write it down if you don't know it? Ammonia. Ammonia is a base. Okay? And if that reacts with water, then it takes a hydrogen from water and it becomes an ammonium ion and an hydroxide ion. Okay? So if you check Arrhenius, a base produces hydroxide ions. True, it produces hydroxide ions. Okay? Now we take another base. That is called what? No. No.
It's calcium.
You don't have to say mono, just calcium oxide. Or burnt lime. Burnt lime or calcium oxide. If you see that oxygen there, it means it is a base. A basis. Okay, so what Arrhenius thought is he thought that this O goes to the water and that we have a calcium ion and two hydroxide ions. So he thought that is what happened, but that is not true. Okay, what actually happens is this one, calcium oxide, splits up in the presence of water to give you calcium ions and oxygen ions. So his definition of a base produces hydroxide ions is not always true. It didn't produce hydroxide ions. Okay, so we saw that there's a mistake in his definition. Sometimes it does work, sometimes it doesn't work. Okay, so that's why we still use it, because most of the time it does work, but there are exceptions. And then two very clever guys that did all of these experiments, they came up with new definitions. So this is the definitions that we ask more. And it's called the Lowry-Bronsted theory. Lowry-Bronsted theory. Okay, Lowry-Bronsted theory. And it says here that an acid is a proton a donor. It gives away. Donor means it gives off, gives away. Proton donor. And a base is a proton acceptor. It takes a proton. Okay, so this is a definition that we will use a lot. A lot. Lowry-Bronsted theory.
When we get female scientists, they do this.
What? Do what?
They thinks this.
Mostly men. It's not woman.
Sorry, second. Do we get famous?
Female.
Yes, there's a very, very, very famous female scientist, Madame Curie. She was not actually French, but she ended in France. She's from Poland. She discovered radiation. So if it wasn't for her, then we wouldn't have been able to cure cancer.
Can cancer be cured?
Stage 4.
Yes, when you radiate it, when you kill the cancer cells,
It dies.
it dies, gone. So my mother has had cancer twice, and currently she's in brain. Even brain cancer.
Then so, what? How do you kill it?
You shoot it with a wave with a specific energy, and then it blows up the cancer
You
cell.
put your body in that machine that does that. Once you come out,
Or so it's either radiation or they use chemo. Chemotherapy is poison. They put poison in your body, and then that poison kills the bad cells, but it also kills the good cells. So some people become very fragile with chemo. No, there is a cure. A lot of people live.
for HIV, for cancer.
Maybe.
When they say stage 4 cancer, you cannot pretend to.
It depends. It depends. There's so many different types of cancer, and it depends where the cancer is. And like the second time my mother had cancer, it was next to her main blood vessel, so they couldn't shoot it. So she had to drink the poison. But if it was another place, then they could have shoot it. So it depends on where it sits and what they can do and blah blah blah.
So they see in the skin that it's dying.
Yeah. All right. Okay, guys, calm down. There is cures for cancer. It depends what type of cancer it is. But anyway, we're not going to go. Famous scientist, Madame Curie, she came up, or she discovered, not came up with, polonium-84. Element 84. She was a very proud Polish woman, so she named the element after Poland. But she also discovered radium-88. And unfortunately for her, radium was more radioactive. So we use radium more for chemotherapy, and she was very sad about it because she wanted polonium to be more used because she wanted her country to be lifted. She did win a Nobel Prize. She is dead. All right. But there's lots of famous scientists, female. Why do we speak about stuff like this? But the time's going to be finished. But